In this example, we're asked to find an approximation for the area of this circle using that 22/7 as an approximation for pi. Now, again, we use our three-line working, we write the formula, we substitute into the formula, but here we're going to use, instead of pi, we're going to use 22/7, and then we're going to write times. Now we need the radius squared. The radius is 5 metres, so we need 5 metres, and we need to square that. So here you might want actually an extra line. When I say three-line working, I mean 3 lines at least. We need 22/7, and we need to multiply that by 25 metres squared, or square metres. All right, now at this point, you could use a calculator, or you could actually do 22 times 25 and divide it by 7. Now how do you do that? Well, over on the side here, you can do 22 times 25 with one of these. Add them together and you get 550. So we want 550 metres squared divided by 7. How do you divide it by 7 without a calculator? Let's go up here where we have a bit of space. And again, you can do these bits of working over on the side. 5 divided by 7 doesn't go. 55 divided by 7 gives me 7, a remainder 6. 60 divided by 7 gives me, 7 8s are 56, and I've got 4 left over, so I could actually keep going here, putting a decimal and as many placeholder zeros as I like to continue on. 40 divided by 7 gives me 5, remainder 5, and I can continue on this way. Now if I was to round this off to one decimal place, I'd say 78.6, because the 7 there will round the 5 up. So now I've got a pretty decent approximation there without using a calculator. An extended skill for those who like a bit of a challenge is to be able to work backwards. Now, can you find the radius of a circle if you know its area? Absolutely. Let's start by, as always, writing out our formula. The only difference here is that in the second step, where we substitute in what we know, the thing that we know is actually the area. So we write 40 square metres on this side, and on this side, we write pi times radius squared. Now, the radius is the bit that we don't know, so we just need to use our equation solving skills here to get the radius by itself. Now, at the moment, this radius squared has been multiplied by pi. How do you want to do that? Well, you can divide by pi. So if you divide by pi on this side of the equation and this side of the equation, the pi's will cancel on this side, and you'll just be left with the radius squared. Now, if you like to write that out nice and tidy with the radius on this side, you could just, it's like a seesaw, they can just change sides. The radius squared is now equal to 40 divided by pi square metres. All right, now if you know what something is when it's squared, what is it when it isn't squared? Well, to find what it is when it's just been itself and it hasn't been squared, you take the square root of it, because that's the opposite of squaring something. But to make up for it, you have to square root the opposite side as well. So here, we reach for our calculator and type in the square root bracket, and then inside it do 40 divided by pi, and we will have a radius. Can you still see that? No, oh, right over here. We have a radius of 3.6, say, and this is in metres, and that is to one decimal place. So here you're using what you've just learned and using your equation solving skills to work backwards.